Okay, so for our lecture for today, so that is probability. Now, in probability, first we need to do is to recognize all the terms that we need. So here are some of the terms in probability. So the first one, we have the experiment or a probability experiment. Next, we have outcome, and then the sample space, and lastly, the event. So, a probability experiment is an action or trial through which specific results, counts, measurements, or responses are obtained. So, the result of a single trial in a probability experiment is what we call an outcome. Now, the set of all possible outcomes of a probability experiment is what we call a sample space, and an event is a subset of the sample space. So let's have a simple example. So for example, let's take the experiment tossing of a coin. So this will be our experiment or a probability experiment. Now, for this experiment, our sample space is consist of the outcomes heads and tails. So we let heads as H and tails by T. Now we can write the sample space using this notation. So this H and T are what we call outcomes. And for example, if we let A be the event, heads up, so we can write the set A as this. Okay, so we proceed now to the definition of a probability of an event A. So our notation for that would be this. So we read this as P of A. So P of A is equal to the ratio of the number of outcomes in the event A to the number of outcomes in the sample space. So for example, in our previous example, we let A as the event heads up. So if we take the probability of A, so that means that we are going to find the probability of getting heads in a single toss of a coin. So we take the number of outcomes in the event A. So we have 1 over the number of outcomes in our sample space. So we have 2. So therefore, the answer would be 1/2. So these are some properties of a probability of an event. So the first one, the probability of an event must be between 0 and 1 inclusive. So we do not have any negative probability or a probability that is greater than 1. For number 2, the probability of the sample space is always equal to 1. So if we are sure that the event will happen, so your subjected probability would be 1. And then lastly, the probability of the null space. The null space is the event that has no outcomes. So if we take the probability of the null space, it must be equal to 0. Okay, so let's have probability distribution. So the first thing that we need to know in probability distribution is what we call a random variable. So a random variable, it is a numerical value associated with each outcome of a probability experiment. So in other words, a random variable is a mapping between the outcomes of a probability experiment to a real number. Now, in types of random variables, we have discrete and continuous. So a discrete random variable, these are random variables that has accountable values, while continuous, those are measurable values. So let's have discrete probability distribution. So a discrete probability distribution lists each possible value the random variable can assume together with its probability. A discrete probability distribution must satisfy these conditions. So the first one, we have the probability of x for all values of x in the discrete random variable must be between 0 and 1 inclusive. And the second one, if we take the sum of the probabilities of each value of the random variable, so it must be equal to 1. So for example, in our previous example, we tackled the experiment tossing of a coin. So we know that the sample space here would be the set that contains the element H and T, and we let A be the event heads up. Now, if we take X be the random variable, the number of heads, so this is a random variable. So the possible values of our random variable X would be 0 and 1. Now let's have a table for this random variable X. So we have X here, so 0, 1, and then below we have P of X. So if we take the probability of X that is equal to 0, that means we are getting the probability of getting no heads up. So meaning that is the probability of getting tails. So the probability of getting tails in our example would be 1/2, and the probability of getting one head in tossing of a coin is also 1/2. Now, checking the conditions of a discrete probability distribution. So each value of the random variable x has a probability between 0 and 1. And if we take the sum of these probabilities, the answer is 1. So hence we can say that this is a discrete probability distribution. For the continuous probability distribution, so we will tackle the so-called the normal distribution. So this graph shows the normal distribution. So the normal distribution has a bell-shaped curve with parameters mu and sigma. Mu is what we call the mean of the normal distribution, and sigma the standard deviation. So our notation for a probability distribution that has a normal distribution, we have this notation. So let us take this example. So a survey indicates that for each trip to a supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes in the store. The length of time spent in the store are normally distributed and are represented by the variable x. A shopper enters the store. So letter A, find the probability that the shopper will be in the store for each interval of time listed below. Letter B, interpret your answer when 200 shoppers enter the store. How many shoppers would you expect to be in the store for each interval of time listed below? So to do that in Excel, we may click this fx and then find norm.dist. So here it is. So we click this, and then as you can see, we have x, mean, standard deviation, and the cumulative. So to answer number 1, so between 24 and 54 minutes, so we are looking at the probability that x is between 24 to 54. Now to do that, we may use the equality that the probability that x is between a to b is equal to the probability that x is less than b minus the probability that x is less than a. Okay, so let us do that. So let us first find the probability that x is less than 54. So to do that in Excel, we may type in here x is 54, and then the mean, so that is 45, standard deviation 12, and then for the cumulative, so we use the word true. And then you click OK. So here's the probability that x is less than 54. Now let us find the probability that x is less than 24. So to do that, let us repeat the procedure. So we go to fx, norm.dist. So we put x be 24, mean 45, standard deviation 12, and the cumulative we have true. And then you click OK. Okay, so this is now the probability that x is less than 24. Now to find the probability that x is between 24 to 54, so we can subtract this to this. So in Excel we press equals, and then we put this, then minus this, and then you press enter. So you will have our answer. And then for number 2, so more than 39 minutes, so we are looking at the probability that x is greater than 39. So in Excel we cannot do that directly, so we will use the equality 1 minus the probability of x less than 39. So let us first find the probability that x is less than 39. So we use again Excel. So let us press fx norm.dist. So for x we type in 39, mean is 45, standard deviation 12, and for the cumulative we type true. So we press OK, and then after that let us do equals, then 1 minus, and then we pick our answer earlier, and then we press enter. So this gives you the probability that x is greater than 39. So to answer letter B, so we will multiply the probability in letter A by 200. So we have 200 here, so I'll type in 200. So we have equals, so 200 multiplied by our answer in letter A. So we press equals, so this gives you 146.6627, or rounded up, that would be 147. So we can interpret it as, so in 200 shoppers that we will enter at the store, so we can expect at the interval 24 to 54 minutes we have 147 shoppers. And then for letter B, so we have equals, so 200 times our answer in letter B, and then we press enter. So we have the value 138.2925, or 139. So we rounded up. So to interpret that, so in 200 shoppers that will enter the store, so 139 would be the shoppers in the store in the time interval 39 minutes and above.